Morning all, Lee from Fry's Garage here. I wanted to share a little diagnosis with you, which unfortunately has cost the customer quite a bit of money for something really silly. All right, now it's a Mitsubishi Triton MQ 2015-16, I reckon they started. Now, he came to me because he'd gone to a mechanical workshop and they said the aircon compressor, the clutch was burnt out. So they changed the aircon compressor and then worked out that it still wasn't engaging. So there was no power there, obviously. So long story short, aircon wasn't working. It's come to me and I tested the clutch, obviously been new compressor, everything's kosher. All power supplies were good. Now this has non-climate or auto control of the AC or climate, so very basic. So I'll just standard manual. Okay, so we got your standard vent controls, fan, AC on or off, demister, hot and cold, and recirculation and outside vent. So mechanical cables to the doors, very basic air conditioning system, the ones that I actually like because they're so easy to diagnose. Usually you got to go if you're a gut feeling, and when you know how the aircon systems work. Look, it's not rocket science, it's really not. So look, I went through the basics, checked the AC relay, and the computer wasn't switching the coil for the AC relay. So what I did is I manually bridged the relay, which is in the engine bay, to a ground, because the computer, the engine ECU, actually switches the ground, which is pretty common these days. Now unfortunately the ECUs are linked even to the mechanical AC heater systems, because one of the main reasons is the engine RPM is raised at idle. So if you're at the lights and you turn your aircon on, you'll pretty much would have felt that and seen the engine RPM raise generally to around the 850-900 RPM mark, and that's to keep the compressor up and sort of keep the power going, alternator generating power to the battery, and also the integrity of the aircon system is much better at a higher idle. So in the summer you want to keep cool, and that's how they do it. So unfortunately the ECU is involved. Now the biggest problem is if there is a wiring short on that circuit for the AC, it can potentially blow up the driver circuit for the ECU, and now in this case that's exactly what it's done. And the reason I want to share this with you guys is because this vehicle has been fitted with an upgraded aftermarket double DIN type stereo touch screen type unit, multi-function center. And when they put it in, what they've done is they have one of the brackets is cut through and shorted out on the actual thermistor. All right, so the thermistor or thermo temperature sensor that goes into the evaporator underneath the dash for the aircon unit was shorted. And what that's done is, unfortunately, those wires go straight to the ECU, because the ECU sees what the temperature is and cuts out the compressor basically. If it's too cold or it's too hot. So it's got a temperature range, because obviously if we keep it running too much, the pressure goes up and it can potentially ice up as well. So that's controlled within a nominated range, which is specified by the manufacturer in this case, but very common specs here for Australia and the warmer countries. So look, why the thermistor wires, which is two wires. So the thermistor's under the dash, it's two wires, small plug, and that plugs into the thermistor into the box, and then it goes in under the dash to the dash loom, through to the main loom and down to the ECU. So why they have put, now I'm assuming the reason that there's a joining plug behind, get there for you, behind this whole fascia here, is because you can get the fancier model with the auto climate control. So with the auto climate control, I would say generally, if you see these little slots in any of the dash cowlings or the fascias, that's basically, behind that is where the cabin temperature sensor is, and that's part of the auto climate control circuits. This one doesn't have it, so they've got a couple of plugs around here. Anyway, so I'll just show you the circuit diagram. So this is how I came up with this. So I talked to my good friends at Mitsubishi, and they sent me a wiring diagram because I couldn't find it anywhere. Very, very basic system. So we've got the engine ECU, okay? We have the AC compressor relay, all right, which is fed by fuses, okay? So your main fuse, which comes and jumps when the relay latches and goes straight to the compressor, AC compressor. And then you've obviously got another ignition fuse that will come through to the coil side of the relay, and then the coil is grounded via the engine ECU when it is happy that one, the pressure switch on the high side air conditioning pipe is got a closed circuit when the engine is idling. So basically, when that closes, it basically means that there's gas in the circuit. All right, so we don't want the AC compressor cutting in or engaging if there's no gas in the circuit, because we're going to damage the pump. Okay, so the pressure sensor is part of the ECU circuit, and also the fin thermo sensor, or the thermistor, okay, or the thermostat. We call them both, all right? So thermostats are generally sort of more mechanical, mercury filled, bit old school. Thermistor, electrical basically. So they have like a little carbon interior that notices and is very sensitive to temperature differences. So what it does is it changes resistance, and the ECU notices the resistance. Now generally, thermistors at ambient temperature between, I think it's 20 25, you're looking at it around 1500 ohms. So if I put a multimeter, let's say on one side of the plug and the other side of the plug, all right, we'll get about 15 ohms between 20 and 25 degrees. Now when the air conditioning is on and this thermistor is in a very cold environment, the resistance drops, okay? And when it drops so far, the ECU, which is probably designed at a set point of, let's say, 900 ohms, will say, right, it's cold enough, it's going to start icing up, we need to turn the AC compressor off. So then what will happen, very simply, is the ECU will cut out the ground and allow the AC relay to unlatch, which in turn turns the compressor off, okay? So yeah, look, very simple. The blower switch, that's an input to the ECU, and then there's CAN lines. That's not part of the climate control. That's just diagnosing for other, for your diagnosing the engine ECU. So when you plug in your OBD2 connector and the like, I don't even know why that's on this diagram, because it's climate control and AC heating only. So I tested the relay. So we had power. I could get this with a separate power on the compressor to engage, which it did. And also what I did is I got a bit of wire and I bridged from the relay connector straight to engine ground, okay? And this relay engaged and the AC came on. So I knew that whole circuit there was good. Powers, ground, compressor, but I'm missing this ground. So the first thing I checked was the pressure sensor. Yes, it was closed, continuity, engine off, ignition on. So that signal was reaching the ECU, and I could see it on the scan tool. And the thermistor, well, I had continuity from 1 to 61. It's actually 16, believe it or not, because Mitsubishi and the Japanese translation for the manuals, everything's opposite. So when you see 61, it's 16, 85 is 58. It's quite comical, some of these, so you got to be really, really careful. Got quite dangerous actually if you're playing with ECUs and control modules. But anyway, any good mechanic will know sort of to just double check things and look at pin positions, and just double check wiring coding colors. All right, so that's your key indicator, because that doesn't change, but the pin numbers do, unfortunately. So I had continuity there, and then I had an intermittent problem between the other side of the thermistor and down here to pin 85, which is 58. So if the ECU wasn't seeing the temperature, which in this case is a resistance reading, then it wasn't going to be happy, and therefore it would not switch the ground. Okay, so this aircon relay, or the AC compressor relay, would never ever turn on. So what I did is I made a bridging wire from 2 to 58, 85, all right, and lo and behold, the air conditioning came on. So unfortunately, when I tested the output at the ECU, for the ground here, it was giving me 5 volts all the time, which basically tells you that the ECU board, or the driver part of that board, is damaged. All right, generally with most ECUs, engine control modules, transmission control modules, if the computer is giving the ground for that circuit, or switching the ground, generally when you measure at here to ground, you will see ignition voltage. When you engage that circuit, or when the ECU engages that circuit to become a ground, you'll notice it goes from ignition voltage to sort of 0.1 volts or less, which means it's a ground. Okay, so this basically changes from a positive to a negative. Okay, so kind of like alternators with an alternator light. The alternator light stays on, and then obviously when it starts spinning, it changes polarity, and the light goes out. Same principle. Anyway, so what I did is I had to find what was going on with this here. Where was it? It was basically open circuit, then closed circuit, open circuit, closed circuit, high resistance, and like, oh gosh, so the computer's not going to like that. So I got into my friends at Mitsubishi and asked for, where is plug D136, which is a 2-pin, where is it? Oh my god, where? Oh, there you go. D136, a 2-pin plug. Okay, and looking here, that plug, it's just basically looped, right? And what I'm thinking is the climate control units, or heater / cooling systems that have auto, and even the early manual ones, the thermistor run through what we call a amplifier, because that's what the circuit needed, just to make sure that the resistance was a measurable value that is seen quite quickly. So it had a bit of integrity there. But in this case, it doesn't need an amplifier. The thermistor and the ECU work together good enough to give a reading that works. So anyway, so the guys at Mitsubishi rang me and said, Lee, D136 is behind this fascia panel here. And I'm like, interesting. This is a new unit. I think I know where it might be the problem. So I took it all out, and lo and behold, I found the plug D136 and the grey wire. So this side, grey, GR is just grey for Mitsubishi, and most actually, had rubbed through between 2 brackets when they put it in, short-circuited, because you can see there is no fuse there. It's just a continual line, and it's resistance. Okay, so it's resistance monitored. So for some reason that computer didn't like that, so it damaged the circuit in the ECU for the driver, which allows the ground to become when it's required. So what I've done is the customer gave me a second-hand ECU from the wreckers. So I've used a good old flash tool, and I've rewritten and coded it. I removed the unit, fixed the wiring, looped it. Now I've got full continuity from here to here, and at a resistance that I knew. And at the time, well, it was about 12:30 this morning when I worked it out. Just trying to get this thing going because he needs the aircon and needs to get to work and back, so he's my priority. Yeah, I got a resistance of 1450 ohms at that temperature, which was, I think at that time, probably about 27 degrees, I reckon, around there. Yeah, so with the resistance, yeah, it would have come down to about 900 or 1000. It'll cut out, and then obviously when the evaporator temperature starts rising, then the resistance value will go up again to a point that's set by the computer. And then when it gets to that point, the cut-in will come in again and the compressor will kick in again. So guys, at the end of the day, yeah, had to change one of these. All right, engine ECU module. It's labour time. An aircon compressor was fitted for no reason. Well, that's just bad diagnosis from the original workshop. That's all right. Everyone has their bad days. But please, when anyone is installing, especially these units, all right, you've got to take a lot out. There's a lot of brackets, there's a lot of looms. Be careful, don't just jam them in there. Just make sure your looms and your plugs behind are nice and, you know, secure. They're not going to interfere or get crushed anywhere, and just gently put it in. If you have to force that and you have a gap around here, there's resistance, something's not right. And there we're talking, you know, like 20 gauge wire, very, very small. It won't take much to jam that between a ground, or just cut it or short it to a power source, and you got problems. All right, so that's why I'm doing this video. Look, it's just a run-of-the-mill diagnostic video, but if I can save someone from going through this, it's going to be a $2,000 exercise, no problems whatsoever. Unfortunately, for what? For one small silly mistake. Anyway, that's how it is. I'll do a few more videos like this, especially if I can just help you guys out there and just try and eliminate, or potentially just, yeah, make sure nothing is done like that accidentally. Accident, yeah, reduce the accident possibilities is what I'm saying, I guess. So yeah, all right, we'll see you next time. Hope that was a bit informational for you. If you want to know how aircon works, or you got a question, whatever, you can always PM me, email me, write something on YouTube in the comments there. I'm here for you guys all the time. All right, so I'll talk to you soon, and take care of yourself. Cheerio.